G'day guys, we've got a physics problem on nuclear energy today where we've got to first calculate the mass defect of a Krypton 92 atom. We've then got to calculate the binding energy of a Krypton 92 atom, which we have to express in both joules and electron volts. And finally, we've got to calculate the binding energy per nucleon in electron volts for the Krypton 92 atom. So let's get cracking. First of all, we've got to calculate the mass defect for a Krypton 92 atom. So the mass defect, let's just write down our little formula. We're going to go mass defect of a Krypton 92 atom is going to be the mass, let's just call it of the parts, subtract the mass of the whole. Now, what we've got here is the mass of the parts. Let's start by working out what parts we have. So Krypton 92 atom has 36 protons, so let's write that down. We have 36 protons. And we have 56 neutrons. Cool, so we're going to use these two figures as well as our data that they've given us in this table to calculate the mass of the parts, and we're going to sum them both together. So let's do that. So the mass of the parts is going to be equal to 36 multiplied by the mass of a proton, 1.007276, add the number of neutrons, 56, times the mass of a neutron, 1.008665. And what we're going to do is from that, guys, we're going to subtract the mass of the whole. So the mass of the whole is going to be equal to 91.92616, because here is our mass of a Krypton atom in atomic mass units right there. So we're going to minus away 91.92616. And once we've put those two together and minus that, the mass defect of this Krypton atom is going to be equal to 0.821016. Now we've got to make sure we put our units in, atomic mass units, which we can just write as U. Cool. So that's part A done. Let's get cracking on part B. So, part B asks to calculate the binding energy of the Krypton 92 atom in both joules and electron volts. Okay, so what we can do first, the easiest one, if we have our mass defect in atomic mass units, we can figure out the binding energy in mega electron volts. So we're going to call it, like, here we go, binding energy in mega electron volts is equal to our mass defect multiplied by 931. Now this 931, guys, is just a conversion factor from mass in atomic mass units to electron volts. So it's a handy little conversion to know. So what we can do is from there, we're just going to go, well, this is equal to 0.821016 multiplied by 931. And we get a binding energy in electron volts of 764.37 mega electron volts. Cool. So, guys, if we're going from mega electron volts to joules, what we can do is, if we're going to write our binding energy in joules, is going to be equal to our binding energy in mega electron volts times by 1.6 times 10 to the power of negative 13. Now again, guys, this is a conversion factor from binding energy in mega electron volts to binding energy in joules. So what we can do is once we just put those two numbers into our calculator, we get a binding energy in joules of 1.223 times 10 to the power of negative 10 joules. Now that's per atom, guys, so you'd expect it to be quite small. So let's go onto part C, where we're going to do that. Let's just give ourselves some space over here. Part C. Okay, so calculate the binding energy per nucleon in electron volts for the Krypton 92 atom. Okay, so as you can see here, guys, Krypton has 92 nucleons. So we're going to, let's just write that down. So Kr has 92 nucleons. And so from here, guys, all we have to do is get our binding energy in mega electron volts, which is here, and divide that by 92. So we can say that the binding energy per nucleon is going to be equal to 764.37 divided by 92. And that, my friends, is going to be 8.308 mega electron volts per nucleon. Okay. So, guys, this problem, if you understand the, if you know the conversion factors from mega electron volts to joules and from atomic mass units to mega electron volts, these problems aren't too complicated. Finding a mass defect is as simple as just multiplying a few numbers and working out what the total is and working out what the combined total is. It's not that complicated. The only tricky part is making sure that you have all of these conversion factors under control for converting between mega electron volts and joules, or atomic mass units and mega electron volts. And if you have all these under control, then it shouldn't be a problem at all. You would usually get this table, so you won't have to remember these kind of numbers. You won't have to remember that a neutron is 1.008665. You'd expect to get these numbers given to you. But apart from that, guys, I would just recommend going through a few of these as practice, and just to make sure that you've got where you have to use all the conversion factors. But again, not a very complicated part of your physics course. So I hope the video helped, guys. If it did, give it a thumbs up. Subscribe to my channel. I put out new videos all the time. But until next time, guys, just keep plugging away. But most of all, keep enjoying your physics. And I'll see you here again soon.